Okay, I think I'm live. Can anyone confirm that in the chat box, please? Yeah, I think I'm live and my audio should be also good, right? Okay, so I've got the confirmation that I'm audible and clearly visible. So we can start the session for today. Yeah, so hello and welcome to this session. Welcome to this free video series by Team Cracku. Yeah, this is for IIM Bangalore's UG admission test. I hope you must be following us on this channel. Yeah, so today's session is a revision session on algebra. So basically we will be solving questions from inequality as well as logarithms, right? Because we have already covered these topics, so this is a revision series. So today's topic is inequalities as well as logarithms. And if you have come on our channel for the very first time, then I would request you to subscribe to this channel and also like this video, because this is a free video series that we are providing you. And the if you are subscribing to this channel, that motivates us to bring so many such sessions for you in the future. Okay. So I think with everything being sorted, we can just start with today's session. But before we begin, I have a few updates for you. Right, starting with this, that is the WhatsApp channel. Right. So all the free updates regarding this IIM Bangalore's UG admission test, we are providing all the free preparation resources in this WhatsApp channel. And apart from that, the important updates regarding the sessions that we are conducting, as well as the updates regarding this entrance exams, all those updates will be shared in this WhatsApp channel. The link you will be able to find in the description box. So if you have not joined this WhatsApp channel, then I would recommend you to join this WhatsApp channel. Okay, it will be very helpful for you in your preparation. Okay, so this was about the WhatsApp channel. And also we are providing 5 free mock tests for IIM Bangalore's UG admission test. These mock tests are prepared by experts. All you need to do is just visit this website, that is cracku.in/IIM Bangalore's UG mock test. You just need to register yourself and you will be able to attempt these 5 mock tests. Okay, just visit this website and you will be able to attempt the mock test for free. These are 5 free mock tests. So this was the update. Okay. So like I told you that today we will be looking at some basics, because these topics are already covered. Then our focus will shift to solving of questions. First I will be giving you a bit brief about inequalities as well as logarithms. Then we will be solving a lot of questions. Okay. So first we will be looking at a bit about the basics of inequalities and logarithms. Okay. I can't find anything in the chat box as a doubt, so we can start. Yeah. So starting with inequality. So basically we have these 4 signs that you will find when you will be solving questions from inequality. That is less than equal to, greater than equal to, and less than or equal to, less than or greater than. Okay. So let's say if I write, let's say any variable x is less than 2. So this means the values of x will be less than 2. On the number line also you can say that if this is 2, then the values of x are less than 2. So the values of x, the values that x can take will be 1, 0, -1 and so on. Right. So this basically means less than. So जो x है वो 2 से छोटा होगा. Okay. Similarly, if I write x is greater than 2, I'm just telling you the basic understanding of these terms so that we can start solving questions, right? So this was less than. If I write x is greater than 2, this means x can take values that are greater than 2, be 2.5, 3, 3.5 and so on. Depending upon if it is integer, then the values that it will be taking will be 3, 4, 5 and so on. If it is not an integer, then it can take values as 2.1, 2.2 and so on, right? So this was about the 2 basic signs. Apart from this, we have these 2 signs also, that is less than equal to, greater than equal to. If again taking the same example, if x is less than equal to 2, so all the values that are less than or equal to 2 also, right? In the first case we saw that x can take values that are less than 2, that is if it is an integer, then 1 0 minus 1 and minus 2 and so on. But in this case all those values will be counted, but apart from this 2 will also be counted because the x is either less than 2 or equal to 2 also. Okay, similarly if we have a condition that x is greater than equal to 2, now again using the last example that x can take all the values that are greater than 2 as well as equal to 2 also. So x can take all the values that 2, 2.1, 2.5, 3 if it is not an integer. If it is an integer, then x will be taking the values as 2, 3, 4, 5 and so on. Okay, so this was basic understanding about the signs. What are the critical points? We'll be able to understand this with the help of this example that I have taken here, right? So while solving the inequalities, you will find a lot of questions in this particular format, right? So if you will get, let's say it is written that x minus 3 is less than 0. If it is written like this, so this is the basic inequality. So for critical points, all you need to do is you can just put this term equal to 0. That is x minus 3 is equal to 0. So x is equal to 3. So 3 is the critical point, right? Similarly for the second term also, x minus 4, if let's say if we had x minus 3, x minus 4 is less than 0, then the critical points will be, you can just put the two terms equal to 0 and you will be able to get the critical points. So x minus 3, so x will be equal to 3, that is the first critical point, and x minus 4 equal to 0. So x is equal to 4 is a critical point. So this is the basic understanding about the critical points. Okay. Now you need to understand how we represent this on the number line. But before this, let's try to understand this, that how change of inequality sign when multiplied by a negative. Okay, let's try to understand this with the help of basic example. Let's say if I write 3 is less than 5, right? So this is right? 3 is smaller than 5, so this is I can write in terms of inequality that 3 is less than 5. So I can if I multiply with some number on both sides, let's say I multiplied by 2 on both the sides, then what I will get here is 3 multiplied by 2 is less than 5 multiplied by 2. So again 6 will be less than 10, right? And so on. Whatever number I multiply here and here, this inequality will be same. But in case I multiply with a negative number, for example, let's say I multiplied it by in the last example I multiplied it by 2. Let's say if I multiply it by minus 2, so here what I will get here is 3 multiplied by minus 2. Here it will be 5 multiplied by minus 2. So this will be minus 6, this will be minus 10. Now you know that the minus 6 is greater than minus 10, so the sign of inequality will change, right? Initially the sign was that 5 is greater than 3, but now I have multiplied both the sides by minus 2, so the sign of inequality will change. So this is an important thing that you need to know here, is that if you are multiplying with any positive number, then the sign does not change. But if you are multiplying with a negative number on both the sides of an inequality, then the sign of the inequality will change. Okay, so this was the basic understanding about changes of inequality sign when we are multiplying it by a negative number. Okay, I hope this should be clear. And also now let's look at representation of inequality on number line. So again, taking the example that I have took here, that is x minus 3 multiplied by x minus 4 is less than 0. Okay, so I am taking an example that is x minus 3 multiplied by x minus 4. So this is less than 0. Okay, so this is less than 0. So if we want to represent this on the number line, the first step would be to find the critical points. Whenever you are solving any inequality, the very first step is to find the critical points. Okay, so for critical points, like I told you, you can just put these two terms equal to 0. So x minus 3 equal to 0 will give me 3, and x minus 4 equal to 0 will give me 4. So these are the two critical points. Now to represent it on the number line, I just want to write these values on the number line. This is 0, right? And here all the values will be positive, and on this side all the values will be negative. Okay, I hope you know the basic understanding about the number line. So here it is positive infinity, all the positive values from 0, and here it is a negative infinity, right? So we have the two values that x is equal to 3 and x is equal to 4. So I can just write, okay, take the value here as x is equal to 3 here and 4 here. Now I need to see, I need to put some values from the number line and see whether the term is positive or negative. If I take any value that is greater than 4, let's say if I take value 5 or 6, I'm taking value as 5. So if I put 5 in the equation, what I will get here is 5 minus 3 is equal to 2 multiplied by 5 minus 4 is equal to 1. So that is a positive number, right? Because this is also positive and this is also positive, so the product that will come out will also be positive. So whatever value I put greater than 4, the inequality will always be positive, right? So here it will be always be positive. If I put any value that is less than 3, let's say any value that is less than 3, if I put 2, okay, I'm putting 2 here, so 2 minus 3 will give me minus 1. If I put 2 here, it will be 2 minus 4, that is minus 2. So again, minus 2 into minus 1 will give me positive number. So again, this is positive. So I can write here positive, and it will be satisfying for all the values that is less than 3. And for the any value that I put in between 3 to 4, let's say I put a value 3.5 that is in between 3 and 4. So if I put 3.5 here, it will give me 3.5 minus 3, that is 0.5. Okay, so this will be 0.5 multiplied by 3.5 minus 4 will give me minus 0.5. Again, you can calculate the value, but the fact is that this will come out to be negative, right? So the answer that will come here will be negative. So here the answer is negative. Now you need to see what value are you asked to calculate. You want the final result to be less than 0. That is, you want the final result to be negative. And in this interval, you can see that the answer is coming out to be negative. So the answer for this particular term will be negative in this range from 3 to 4, right? Because here also all the values are positive, here also all the values are positive, and you are asked to calculate for that the product of these numbers should be less than 0, that is negative. So from 3 to 4 you can see that the product of these two quantities or whatever it is negative. Okay, so it will lie in the range of 3 to 4. And how you will be able to represent this? See, you will have to represent it like this, 3, 4, right? And the bracket will be open. See, there are two kinds of bracket. One is this, that is open bracket, and one is this, that is closed bracket. This basically means that the end value is not counted. That means that 3 and 4 are not counted. All the values that are between 3 and 4 will be taken as the answer. So because if we put 3 here, then the value will come out to be 3 minus 3 will be 0. So 0 multiplied by any number will be 0. But we want the result to be less than 0, right? But if we put x is equal to 3, then this will come out to be 0, because we do not want 0. So we will put open bracket. That means 3 and 4 are not counted, but all the values that are between 3 and 4 are taken as the final answer. But if we take the closed bracket, that means that both 3 and 4 will be counted. Let's say if we were asked to, we were given that this is less than or equal to 0. In case we were given that this is less than equal to 0, so we will take 0 also, right? So in that case, we would have put the closed bracket. By closed bracket, it means both 3 and 4 will be counted. Okay, I hope the basic understanding about the closed bracket and open bracket should be clear. It will depend upon what values you are asked to calculate, right? So if you are asked to calculate equal to 0 also, then you will take the closed bracket. But if you are not asked to calculate equal to 0, then you will take open bracket. Okay, so this is a basic representation of this on the number line. So this means then you will be taking all the values that are between 3 and 4. Okay, I hope there should be no doubts here. If you have any doubts, you can just ask in the live chat. I can't find any doubts. If you have any doubts, you can just put it in the live chat. So this was the understanding about how to represent on the number line. One more important thing to note here is, you can see that here it was positive, then negative, then positive. So if the power of these terms is odd number, that is 1 or 3 and so on, then this will be first positive, then negative, then positive and negative, and so on. It will keep on changing. If you are able to figure out the first term, that is let's say in this first interval it is positive, and all the terms that are the power of the terms is odd number, then it will keep on changing from positive to negative, then positive and negative, and so on. But if the power is even number, that is let's say square or power 4, then the term, the sign won't change. From the intervals the sign won't change. Okay, but if the power, like I told you, if the power is odd number, then you can directly change the sign. For example, in this particular case, this is kind of a shortcut. In this particular case, if I take a value that is greater than 4, so I took the value greater than 4 and I checked that 5, let's say I take the value as 5. So 5 minus 3 is plus 2, 5 minus 4 is plus 1. So the resultant is positive number. So I can write plus here, and with the help of this plus, I can write minus and plus, and so on. I can keep writing, right? So this is a kind of shortcut that if we are able to figure out the sign in one interval, we will be able to figure out the sign in the remaining intervals also. But the only condition that you need to keep in mind is that the power should be odd number. If the power is odd, because in this case the power is 1, if no power is given, that means the power is 1. So if the power is odd number, so you can just keep on changing the signs in the intervals. Okay, so this was about the representation of inequality on number line. I have also told you about the open interval and closed interval. Now, keeping the coefficient of x as positive, let's try to see what this basically means. So if let's say I am taking the same example, this is x minus 3 and 4 minus x I have written. Let's say this is less than equal to 0. Even though we can solve it using the steps that we used in the last case also, but we generally try to keep the sign of x or x square term as a positive number. That is, we can just take minus common from this particular term. What we will get is, let's say this is x, of course this is x minus 3. Here this is, I can take minus as common, so this will come out to be x minus 4, because I have taken minus common. So minus of x, so this will be minus x plus 4, right? Same as this. So I've just taken minus common, and here it is less than 0. Now I can take this minus outside. This will be minus x minus 3, x minus 4 less than 0. Now to remove this minus, I will multiply with minus 1 on both the sides. So I'm writing it here. This will come out to be x minus 3, x minus 4, and this will be greater than equal to 0, right? Because I have multiplied with by negative number on both the sides, so the sign of the inequality will change, like I told you, right? So I can just take the minus sign outside if I want to convert this the term, that is x term or x square term, to a positive number. So I can just take the minus as common, and I will multiply with it with my minus 1. So the sign of inequality will change. Okay, you can see now the sign of inequality will change, and from here you can just put this on the number line. That is what you will be asked to calculate. And one more important thing is, let's say in one case I get the answer to be in this range, right? If the answer comes out to be in this range, then how you will represent it? See, you will always take the infinity under an open bracket. You will never include the infinity. So let's say if the answer comes out to be in this range and 3 is included, then you will write it as open bracket minus infinity comma this. Okay, if the answer is in this range and 3 is included based on the conditions, then you will write it as minus infinity open bracket here, then comma, then 3. If let's say the second range is this, let's say the second range includes from 4 to infinity, then you will write union, right? This represents union. Then the values of x are in this range also plus in that range also. If we are getting multiple ranges, for example on the number line we get values from, let's say, from this point to this point, then there is some gap, and after this from that point to again some extent. So if the values are in that particular order, so what we need to do is we can just represent it in this particular order, that minus infinity to 3 union means basically this plus this. Okay, both the values are considered as an answer. So likewise, if the range is this also and 4 is also included, so I will write it as close bracket, because I am including 4. So 4 comma plus infinity. And because I said that we will never include infinity in our answer, so whenever it is infinity, we will just take open bracket. Okay, so open bracket minus infinity, comma 3 union 4 comma infinity. I hope this should be clear. I've just taken an example to represent the infinity also. If you have any doubts, you can just ask in the live chat. Okay, I can't find any doubts. So this was about inequalities. Okay, moving ahead then. So this is about logarithms then. So I have included the properties of logarithms, but before we begin with it, first try to understand what is the need of logarithms. Let's say if I ask you to that 2 raised to some power is equal to 8. So what is that power? So you will be able to say that okay, it is 3, because we know that 2 raised to power 3 is 8. But if I say that 2 raised to some power is equal to 6, what is that power? So you will say that it will be lying in between 2 to 4, because 2 raised to power 2 is 4 and 2 raised to power 3 is 8, but you will not be able to find the exact number, right? So with the help of logarithms, we will be able to find the exact value, right? So logarithms helps us to calculate the powers. Okay, so that is a basic understanding of logarithms, that it helps us to calculate the powers. And how do we represent it? So log is basically represented as, let's say I have to represent 2 raised to the power 3 is equal to 8, because with the help of log we are able to calculate the power. So here you will be writing 3, because log helps us to calculate the power, and whatever number is there you will be writing it in the base of log. So here it is base, right? And the number that is on the right hand side, you will be writing it here. So this is the basic representation of log, that 2 raised to power 3 is 8. Likewise, if I say 3 square is 9, you want to represent it in terms of log. So how you will write it? Because with the help of log we are able to calculate the powers. So the power is 2. So in the right hand side it will be 2, and whatever number is here, that is this, you will be writing it in the base of log. So here it will be 3 and here will be 9. So now if I want to convert this into the normal representation, then how I will write it? So this raised to power this equal to this. So 3 raised to power this is equal to 9. For example, let's say I don't know some values. For example, if I write, let's say log 4, maybe if I write 4 raised to power, let's say 4 raised to power 3 is 64, right? So if I am writing it 64 here and I don't know which power it is, okay, I have taken some example that 4 raised to some power is equal to 64. So how I will represent this? So 4 raised to power this is equal to 64. So because 4 is 64, so x will be 3, right? 4 into 4 is 16, 16 into 4 is 64. So x will come out to be 3. So likewise, you can convert log to the normal representation, and from normal representation also you can convert it into log. So this is the basic understanding of logarithms, right? And there are a few conditions also on this base as well as argument. This value is called as base and this is called as argument. There are a few conditions on the two values. We will be understanding that also now. Okay. So these are the two conditions. So the argument has to be always greater than 0. So what was the argument? Let's say I write it as log AB is equal to C. So this was base and this was argument. Okay, so this is base and this is argument, and the condition on argument is that it has to be always greater than 0. So this value, that is B, has to be greater than 0. Okay, one more condition is on base. So the base also has to be greater than 0, but apart from this it cannot be equal to 1. So A has to be greater than 0 as well as A can't be equal to 0, right? So these are the two conditions that you need to keep in mind in case of logarithms, that the base and argument, see there are two terms that are base and argument. So argument and base both should be greater than equal to 0, but base cannot be equal to 1 also. There are two conditions on base and there is one condition on argument. I hope this should be clear. Apart from this, these are the basic properties of logarithms. Okay, if there are no doubts, we can start with the properties also. Okay, so now we can look at the properties of log also now. So if the argument and base are equal, then the result will be 1. If let's say I write log a, here also a, then it will be always be 1, right? Because a raised to power 1 is equal to a, right? So that's why if the argument and base are equal, then the result will be equal to 1. This was the very first property and it is pretty easy. Now again, then the second property is log base to, log with the base a and the argument 1 is will be equal to 0. That is log base a argument 1 is equal to 0. Again, you can understand with the help of the property of log, because we are able to calculate the powers. So how you will represent this? So a raised to the power 0, because we are calculating the power, and the term that is in the base, we will raise that, we will take it to the right hand side, and this, and the right hand term will come to in the power. So a raised to the power will be equal to this value, that is 1, and any number raised to power 0 is equal to 1. So that's why 1 is equal to 1. Even though you do not need to do all those things, but I was just telling how we are getting to this result. So log raised to some base, if the argument is 1, right? If the argument is 1, then this term will be equal to 0. I hope this should be clear. This was one property, that log 1 is 0. Okay, looking at the third property now, that log raised to power some, log with some base a, and the argument is a raised to power x, so this will be equal to x. Okay, a raised to the power x, right? So this is the term. So what basically happens is that if there is any term on the, whatever the power of argument is, we can take it to the front side of logarithms. That is, we can write it as log with the base as well as argument as a. We can take this here. Okay, so if there is any term written in this particular order, we can take the power here, and if we can write it as x multiplied by log base a and argument a. Now you know that if there is if the argument and base is same, then the value of this particular term will be equal to 1. So that's why x into 1 will be equal to x. Okay, so that means this will be equal to x. So the important thing is that whatever power is here, we can just take this here. So x multiplied by log base a argument a. I hope this should also be clear. Okay, we have one more important property, that a raised to the power log a this will be equal to x. Okay, so how we are getting to this? See, there is one property of log, that if there is some number written here and in the power it is written log base some base with argument, so we can just interchange these values. So this is the property of log, that we can interchange these values. So how we can write it as? So x raised to the power log with the base a and argument a. So because again base and argument are same, so this value will come out to be 1, and x raised to power 1 will be equal to 1. So this will come out to be x, that is written here, that is x. So important thing to note here is that if something is written in this particular format, then you can just interchange this value with this. Okay, either you can take this value here, and so on. So this was one important point about this particular property of log. Now let's look at this property, that is log raised to power log, that is base a and argument b. Log with the base a and argument b. So what you can do is, you can just convert it into a different base. That means you can write it as log base divided by log b divided by log a. Okay, you can just convert log that is with the base a and argument b, you can convert this in this particular format, and whatever base you want, you can just write it here. For example, it was in base a, right? And if you want to convert it in some other base, let's say as per the requirement of the question, you want to convert this into base in the base c. So what you can do is you can just write it log c that is in the base divided by log c in the base here as a. Okay, so you can represent this in this particular format. If you want to change the base, so you can just put whatever base you want, and you can just write these two values, one here and one here. So this was the property. Here whatever base you want, you can write. And also in the same case, if you want to just interchange the base and argument, that also you can do. You can just write it 1 divided by log base b argument a. If you are given that log with the base a and the argument b, if you want to interchange base and argument, what you can do, you can just put the reciprocal, that 1 divided by this term, and you can just interchange the argument and base. So these two, both the values are equal. This is also an important property of log. Okay, so this was all about the properties. Now let's look about the product and quotient properties. So if let's say this is written in this particular order, that is log with the base a, and this xy is in the product. So here the argument is x into y and the base is a. So what you can do is you can just write it as log with the base a x plus log with the base a y. Vice versa is also true, right? If let's say you have log with the base a x plus log with the base a y, so you can apply the product rule, that is log with the base a x into y. If the two terms are in, if the two terms are, there is a plus sign in between the two terms, so you can just write the property this, that if log base a x plus log base a y is written, so you can write it as log base a, log in the base that is a, and the argument will be x into y. So the vice versa is also true. So you can write it this term as these two terms and this also in this particular order. I hope this should be clear. This is the product rule. Similarly, if let's say in this case it was x into y, if we have x divided by y, then the difference is a minus will come between them. That is, if this is the case, this is similar to the first case, but the only difference is here the term is x divided by y, so you can write it as x minus log with the base a y, right? So here it was, because it was the product, so the sign will be positive in the between the terms, but here because it is x divided by y, so that sign will be negative. Okay, so these are two important properties, and of course if this is given to you, you can write it this way. If this is given to you, you can write it this way, because both are true, right? Vice versa is also true. This one important property I already told you, that if there is something in the power, you can just take it here, right? So that is k comes here, that is this, then log base a and the argument as x. Okay, so this is, we have already covered. This I think we can understand with the help of this power rule only, that log with the base a and x raised to power 1 by n, right? This basically means that the power is n. So generally we write root x. Root x means, because this is 2 only, right? If there is any power that is apart from 2, then we have to represent it here. But if nothing is written, we assume that it is under root, that is power 2. So basically if something is written like this, then we write it as this. If let's say something is written as in the cube root form, for example some value is written as this, so 3 is written here, that means x raised to power 1 by 3 it is. Okay, so similarly if n is written here, that means the power is not 2, or maybe the value of n can also be 2, but how we will represent it as x raised to power 1 by n, right? So like we write for under root, so we can just write it like this way, and now we can use just the power rule that the value in the power of the argument can come here. So it will come out to be 1 by n log with the base a and argument as x. Okay, I hope this should also be clear regarding this. And this is the last and of course an important property of logs. So if the base is, since like I told you, the base should be greater than 0 and it should not be equal to 1. But in case the base is between 0 to 1. For example, let's say if I take log, okay, let's write it here. I will write it here. Let's say it is log base 2, let's say some power. I'm writing just for an example. So this is written here. So what we do is 2 raised to power x, or let's say I take some inequality to better give you clarity. Okay, let's say it is log base 2 5 is greater than x, right? If this is the case, what you will do is 2 raised to the power x is greater than 5, right? Like just like I told you that the base raised to power this will be equal to this. If there is inequality, you can just keep the inequality same. But in case the inequality is between 0 and 1, sorry, in case the base is in between 0 to 1, then the inequality will again change. That is, if let's say it is log 0.53 is less than x, it is written, then to represent this you will write it as 0.5 raised to the power x will be greater than 3, right? So the inequality will change. You will do all the remaining things as we were already doing, but in case the base is in between 0 to 1, you will just change the inequality sign. Okay, if it is less than, it will change it to greater than, and vice versa is also. Okay, so I hope this should also be clear. This was an important result about the base. I hope this should be clear. This was the last property. Now if you have any doubts, you can just ask in the chat. Otherwise, we'll move ahead to the questions now. Okay, if there are no doubts, we can move to the questions then. Yeah, okay. Try this. This is the first question for the day. So the time is up. Let's try to attempt this question. Find all the values of x that satisfy the inequality below. Okay, we need to find the possible values of x. We are given x minus 3 square, x square plus 9x plus 20 divided by x square plus 2x minus 15, that is less than equal to 0. Okay, so we are given this. Now we need to just simplify this quadratic term as well as this quadratic term. We can just, you can see that okay, the minus 9 we can write it as 5 plus 4 is 9 and 5 into 4 is 20. So we can just break the middle term and we will be able to solve this quadratic term. Similarly, for the term that is in the denominator also, 5 minus 3 is 2 and 5 into 3 is 15. I hope you should be able to do this quickly. If you have done the quadratic question class, you will be able to do this. So I am just solving this term. That will be equal to x square plus 5x plus 4x. It is 5 plus 4 is 9 and the product is 20, right? Here x square plus 5x minus 3x, right? 5 minus 3 is 2 and 5 into 3, that is 5 into minus 3 is will give me minus 15. So this will come out to be x minus 3 whole square. Here I can take x as common, so x plus 5 plus 4 x plus 5. Okay, now in the denominator it is x, I can take common, so x plus 5, right? Now it will be minus 3 x plus 5. Solving it here now, this will come out to be x minus 3 whole square. Here this is x plus 5 and x plus 4. In the denominator it is x plus 5 and x minus 3. Now you can just cancel this out and also one power will be cancelled out. Whenever you are cancelling out the terms, that means that x plus 5 cannot be equal to 0. That means x cannot be equal to 5, right? So x cannot be equal to 5 and also x cannot be equal to 3. If we take x is equal to 3, then the denominator will be 0. So that will come out to be undefined. So that's why x cannot be equal to minus 5. So x cannot be equal to minus 5 because at minus 5 this will be 0, and also x cannot be equal to 3. Now whatever we are left with, this is x minus 3, right? Because this was a square, so one power has been cancelled out. Here it is x plus 4. Now this is less than equal to 0, right? So this is less than equal to 0. We need to just plot it on the number line. For number line, like I told you, first we need to find the critical points. X minus 3 is equal to 0, that is x is equal to 3. X plus 4 is equal to 0, that is x is equal to minus 4. So plotting on the number line will give me minus 4 here and plus 3 here. Plus 3 here. Now I need to check some values. Let's say I put a value that is greater than 3. If I put it as 4, then this will be also positive, this will be also positive. So here it will be positive. And like I told you, if there are the terms that are with odd power, I can just directly write if this is positive, then this will be negative and this will be positive, and so on. Now I am asked to calculate the values that are less than equal to 0, right? Less than equal to 0 means either 0 or negative values. So here it is negative, so this will be the range in which the values of x will lie, and also because this is equal to 0, so I will take the extreme values also. right? So for this particular question, the answer will be from -4 to 3. So this will be the case. But again, because 3 we can't take as 3, so we will not be taking this as an answer because we can't include 3, right? So option number C will be the answer, because in the option number C, 3 is represented with the open bracket and we cannot include 3, so that's why the answer will be closed bracket -4 comma 3 with open bracket. I hope this should be clear, and I hope you would not have any doubts. If you have any doubts, you can just ask in the live chat. Otherwise, we'll move ahead to the next question. Yeah, moving ahead to the next question. Try this. Okay, so the time is up. Let's attempt this question then. Yeah, so in this question we are given that x and y are two real numbers such that x cube and y raised to power 6 is 1. Find the value of the expression this. So we are given that x raised to power 3 and y raised to the power 6, this is equal to 1, and we are asked to calculate the value of log. Let's try to take log on the both the sides. Okay, so let's take log with base, with whatever base we can, with whatever base we want we can take. So if in one condition it is log with the base x, in one condition it is with the base y, so let's take with the base x. Log with base x on both the sides. Okay, taking log with base x on both sides, so it will be log base x, x cube, y raised to power 6, log base x 1, right? Like I told you, if the argument is 1, then this will be equal to 0, right? We learned the property, and here we can apply the product rule. So this will be equal to log base x, x cube plus log base x, y raised to power 6. We have just applied the product rule, and here it will be equal to 0 because the argument is 1, so this will be equal to 0. Now we can take this power here, right? We can take both the powers here, so this will be equal to 3 log base x, x plus 6 log base x y equal to 0. If base and argument are same, then this will be equal to 1, right? So this will come out to be, let's write it here, this will be 3 into 1, that is 3, plus this will be same 6 log base x y equal to 0. So 6 log base x argument y is equal to minus 3. So the value of log with the base x and argument y will be equal to minus 3 divided by 6, that is minus 1 by 2. So we are able to figure out the value of log with the base x argument y as minus 1 by 2. And also because we are asked to calculate with the base y also, so like I told you, we can just interchange the base and argument and we can do the reciprocal. So here itself I am writing it here as log with the base x and argument, base y and argument x, so this will be equal to minus 2. Okay, I have just interchanged the argument and base, and on the right hand side we'll just do the reciprocal. So you figure out the two values. Now let's try to simplify this term. Okay, I'm writing it here then. Okay, simplifying this, that is 3 plus log with the base x raised to the power 7 y raised to the power 3 9 plus log raised to the power y x raised to the power 8 y square. Okay, so now just simplifying this, again I can apply the product rule here. So 3 plus log with the base x raised to the power 7 plus log with the base x, this will be y cube. Okay, I just applied the product rule here. Similarly for the denominator also, 9 plus log with the base y and x raised to the power 8, and here also I am applying the product rule. So the second term will be plus log base will be y and y square. Okay, now we can just simplify it. 3 plus, again this will come here, here also this will come here, so on for all the terms, this power will come here. So 7 log with the base x and argument as x, because these are same, so 7 into 1 will give me 7. So 3 plus 7 plus, so this will come out to be 3 log base x argument y. Now the second term will be 9 plus, I hope this is visible. Yeah, so this will be 8 log base base is y. Yes, so base is y, argument is x, and this will come out to be 2, right? After 2, this will come out to be log with the base and argument as same, so this will be 2. Now we know the value of log base x argument y as well as log base y and argument x. From here we can just put in the values here. Okay, so this will come out to be 7 plus 3 is 10, 10 plus 3 multiplied by log base x and argument y. So base x and argument y is equal to minus 1 by 2. You can just put the value as minus 1 by 2 here. Also this is 9 plus 2, that is 11, plus 8 multiplied by log base y and argument x. So the value of base x and argument base y and argument x is minus 2. So we can just put the value as minus 2 here. So this will be 8 into minus 2. Okay, so 8 multiplied by minus 2. Just need to solve this now. So this will be 10 minus 3 by 2, because 3 into minus 1 by 2 is 10 minus 3 by 2. In the denominator it is 11 minus 8 into 2, that is 16, right? So this will be 16. So just solving this will come out to be 2 into 10 is 20, 20 minus 3 is 17. So 17 by 2, this will be minus 5, or you can write it as 17 divided by 2 into minus 5, or the final answer will come out to be 7, because this is minus, so minus 17 by 10. Okay, I hope this should be clear, right? This 2 will come in the denominator, so 17 divided by 2 into minus 5, that is minus 17 by 10. So it will be option number C. I hope this should be clear. If you have any doubts, you can just ask in the chat, otherwise we'll move ahead then. Yes, Math Magic, your answer is correct. That is minus 17 by 10 for this question. If you don't have any further doubts, we can move ahead to the next question. That is question number 3. So this is for inequalities. Try this. Okay, so the time is up. I hope you must have tried. Let's attempt this question then. Yes. So find the number of all integral values from x belonging minus 5 to 8 such that the inequality holds true. So we need to solve this inequality and we have to see what all values of x are satisfying this interval. Okay, so let's try to solve this. That is x square minus 5x minus 18. Okay, so this was the first bracket. Second is 5x minus x square plus 2. This is less than equal to 48. So this is given to us, and like I told you, we can just convert the term that is x square into positive by taking the negative sign common, right? So we will be converting this into positive by taking minus common from here. So this will come out to be x square minus 5x minus 2. Okay, I have just taken minus 2 common from here. So this will come out to be x square will be positive, 5x will be negative, and 2 will also be negative here, right? So just taking this minus common, and I can just multiply this with a negative sign. So this will come out to be x square minus 5x minus 18. This will come out to be x square minus 5x minus 2. So this minus I can just send to the right hand side, or I can just multiply both the sides with minus 1. So because I am multiplying it with a negative number, so the inequality will change. So this will come out to be greater than equal to minus 48, because I am multiplying it by minus 1. So the inequality will change and minus will come on the right hand side. Now because x square minus 5x is common in the two values, I can just let it to some value so that we can ease some calculation. Let's say x square minus 5x is equal to k. I've taken some variable that x square minus 5x is k. This will help us in our calculation. So because this is equal to k, so this will come out to be k minus 18. This will come out to be k minus 2 greater than equal to 48, that is minus 48. So just solving it now, this will be k square minus 18k minus 2k plus 36, right? Minus 18 into minus 2 will be plus 36. I'm taking this also to the left hand side. This will be equal to plus 48 greater than equal to 0. So now this will come out to be k square minus 20k plus, so 48 and 36 will be equal to 84. Okay, so this will be 84. Now again we need to solve this quadratic equation. I can just break this middle term, that should be equal to 84. So I guess 14 into 6, 14 plus 6 is 20, and 14 into 6 is 84, right? So we can just break the middle term. So this will come out to be k square minus 14k minus 6k. Again both the terms will be negative because this is minus 20. So minus 14 and minus 6 is equal to minus 20, and the product of two negative terms will be positive, right? So minus 14 into minus 6 will give me plus 84. So this is plus 84 here, that is greater than equal to 0. Now I can just take k as common here. So k minus 14 minus 6 k minus 14 greater than equal to 0. So this will come out to be k minus 14 and k minus 6 greater than equal to 0. We know the value of k is x square minus 5x. So this will come out to be x square minus 5x minus 14, right? And this will come out to be x square minus 5x minus 6. Again doing the same thing, breaking the middle term. Here the product is 14. So 7 minus 2 is 14. And here it is 6 minus 1 is 5. Okay. So I can write it as x square minus 7x plus 2x, right? 7 will be greater because the result is negative. So minus 7 plus 2 will give me minus 5, and the product of minus 7 and 2 is minus 14, right? And here it will be x square minus 6x plus x minus 6 greater than equal to 0. Again minus 6 plus x, so sorry, minus 6 plus 1 will give me minus 5, and the product is minus 1. So here you can ask why I have not taken as 2 and 3. So if I take 2 as 2 and 3, then I will have to write minus 2 minus 3, because minus 2 and minus 3 will add up to minus 5, but the product of minus 2 and minus 3 will give me plus 6, but I need a minus 6. So that's why we won't be taking 2 and 3, we will be taking 6 and 1. So minus 6 plus 1 will give me minus 5, and the product of these numbers will be negative. I hope this should be clear. Now I think it is just about, okay, I forgot to write minus 14 here. It is just about writing the terms and then finding the critical values, and then we will be able to figure out the end result. So solving this further, it will come out to be x minus 7 plus 2 x minus 7. So this will be equal to x minus 7 and x plus 2. Okay, similarly solving the second term, it will come out to be, I hope this is visible. Yeah, so this will be x, taking x as common, so this will be x minus 6 plus 1 x minus 6. So this will come out to be x minus 6 and x plus 1. So these are the four values and this is greater than equal to 0. I hope this should be clear. I am again writing it here. So the four terms are this and this, that is x minus 7, x plus 2, x minus 6, x plus 1, and this is greater than equal to 0. Okay, and now I'm writing it here. I think it will not be visible there. So these are the four critical points. Now we can just put it equal to 0. The points will come out to be minus 2, minus 1, 6 and 7. So the points, critical points will be equal to, starting with the negative values, that is minus 2, minus 1, 6 and 7. So these are the four critical values. Now I just need to put it on the number line. So the critical values are minus 2 here, then minus 1, here it is 6 and 7. If I take any value that is greater than 7, so this, all the values will be positive, right? At 8, this will be positive, 8 minus 7 is positive, this is already positive, 8 minus 6 will also be positive, and 8 plus 1 will also be positive, so all the values are positive when I am taking values that are greater than 7. So again I can directly write, if this is positive, so then this will be negative, this will be positive, this will be negative, this will be positive. Okay, and I want the values to be greater than equal to 0. Greater than equal to 0 means I need the positive values. So here from this range the values are positive, in this range also the values are positive, and here also the values are positive. So these are the three ranges or the intervals in which the values are positive. So this will come out to be minus infinity to minus 2, and because it is equal to 0, right, because it is equal to 0, so this will be closed bracket. I can take 2 also, because at 2 this will be equal to 0, and I can take 0 because this is equal to 0. Likewise here also, because union we need to include this interval, this, and also this interval also, so union sign will come in between. So now here it will be minus 1 union, okay, minus 1 comma 6. 6 is also included, I guess, yes, because this is a equal to sign, so the critical points will have a closed bracket. So last interval will be union 7 comma infinity. We never include infinity, so here it will be open bracket. So this is the range, and also these values are also included. We need to find the values in the interval from minus 5 to 8, right? So from minus 5 to 8 we can see all the values are coming here, right? So minus 5, minus 4, minus 3, minus 2, and minus 1 is also included. So minus 1, 0, 1, 2, 3, 4, 5, 6, 7 and 8. So all the values are included, right? So from minus 5 to minus 5 to 8 we can see that all the values are satisfying. So we just need to see how many values are there in this range. So 1 to 8 there are 8 values, minus 5 to minus 1 there are 5 values, and also 0. So there will be 5 plus 8 is 13 plus 1, that is 0, so total 14 values. So for this particular question the answer will be 14. I hope this should be clear. All the values from this particular range will satisfy the inequality. I hope this should be clear. If you have any doubts you can just ask in the chat, otherwise we'll move ahead to the next question then. No, mathematic the answer will be 14. I think you missed a few values here, right? Minus 2 will also be included, minus 1 will also be included, 6 and 7. All these values are, because these are closed bracket, this is equal to sign here, so all the values will be included. I think you have missed 1 or 2 values. You can check, if you have any doubts, you can just ask me. Otherwise, we'll move ahead to the next question. Okay, that is question number 4. This seems to be an easy question. That's why I've given 90 seconds only. Try this. Okay, so time is up. I hope you must have tried this. Let's try to solve this now. Yeah, so we need to find the sum of the series. So we are given that 1 divided by log base 7 argument as k plus 1 divided by log base 8 argument k plus, and so on, right, till 30 it is written. Now we know that when the base is same, then only we can apply some property, right? If the base is different, then we will not be able to apply any property. So because we see that the argument is same, so we can just interchange the base and argument, then we will be getting the base of all the terms as k, that is equal and then we'll be able to apply some properties, right? So from here we can note that we can just interchange the base and argument, then the base of all the terms will be same, that is k, and then we'll be able to apply some properties, because to apply the properties we need the base as same. So to change the base we can just do the reciprocal. So we can write this term as log with the base k 7, right? We have changed the base and argument and we have just taken the reciprocal. Similarly for the remaining terms also we can do the same, that is log with the base k, here the argument will be 8, plus log with the base k argument 9 and so on, plus log with the base k argument 30. Now we can just apply the product rule, because the base is same, we can just multiply the arguments. So this will be equal to log with the base 7, sorry, with the base k. So this will be 7 multiplied by 8 multiplied by 9 and so on. This will be multiplied till 30, right? So to multiply this, we can write it as, because we know if you multiply the consecutive numbers, so we can represent this in the form of this, right? So 30 factorial, that is factorial. We know that the factorial of a number is equal to, we can just represent any number. Let's say if we have a number that is, let's say, n factorial, so how we write it as n multiplied by n minus 1 multiplied by n minus 2 and so on till 1. Okay, so if there is any factorial, we can just keep on multiplying by subtracting 1 from the earlier number. So similarly, if we want to multiply numbers from 1 to 30, So we can write it as 30 factorial. That means 30 multiplied by 29 multiplied by 28 and so on. So here you can see that we have to multiply from 7 to 30. So what you can do is you can write it as 30 factorial, but because in 30 factorial you have multiplied from 1 to 30, but you don't have values from 1 to 6, so you can just divide it by values from 1 to 6. So if the values are getting multiplied from 1 to 6, so that will also represent as a factorial of 6. Okay, so 30 factorial basically means product of all the values from 1 to 30. 6 factorial means product of all the values from 1 to 6, and if I am dividing it by 6 factorial, so the values from 7 to 30 will be remaining. So this is the final answer for this question, and you can see it here because we can just interchange the argument and base. So you can write this term as 1 divided by, you can just interchange the argument and base. So this will come out to be log k will come to the argument and 30 factorial divided by 6 factorial in the base. Okay, so option number B will be the correct answer for this question. I hope this was an easy question. The only thing was to represent this like this in terms of factorial. I hope this should be clear. If you don't have any doubts, we can move ahead to the next question then. Yes, the option number B is correct, Abhiraj and Aviral, your answers are correct. So if there are no doubts, we can move ahead to the question number 5 then. Again, the question from inequality, try to solve this. Which question you are not able to solve, Aviral? But you are able to solve the last question, right? If you have any doubts, you can just mention the question number. Okay, so the time is up. Let's attempt this question then. Okay, so in this question we are told that for how many integral values of x does the below inequality hold? So to solve this, first we will have to solve the cubic equation. See, to solve the cubic equation, first we need to find the root, right? First we will have to find one root of this cubic equation as well as this cubic equation by putting on some values, that is 1, -1, 2, -2 and so on. Then if we are able to figure out the first root, then we will just further divide it and we will be able to figure out the remaining values. So we are given that x cube minus 7x square plus 14x minus 8. So this is the equation that is given to us. To find the first root, we can just put in some values, that is 1 minus 1 2 minus 2, to figure out the root of this equation, right? So if we put 1 in place of x, what we will get is 1 cube is 1 itself, minus 7 into 1 plus 14, again it is 1 minus 8. So this will come out to be 14 plus 1 is 15 and 7 on 8 is 15. So yeah, this is equal to 0. That means 1 is the root. So we are able to figure out the root of the first equation, that is this in the numerator. And now to find the remaining values, we can just do the division part, right? So if 1 is the root, we write x minus 1, right? Because if x minus 1 is the root of any equation, so we can say that by putting it equal to 0, that x is equal to 1 will satisfy the equation, right? So because f1 is satisfying this equation, so x minus 1 is the root of this particular cubic equation. We can divide this now with this x minus 1 to figure out the remaining two roots, because it is a cubic equation, so there will be 3 roots, right? So I can just divide it. This is x cube minus 7x square plus 14x minus 8. I hope you must have done this during your school also. So I can just divide this from by x minus 1 to figure out the remaining two roots. Okay, so multiplying this by x square will give me x cube minus x square, right? So this will cancel out. So this will be minus 7x square plus x square. This will be minus 6x square plus 14x. So multiplying it by minus 6, then minus 6x, because minus 6x will give me 6x square. So this will be minus 6x square, and second term will be plus 6x. This is plus, this is minus, so this will cancel out. This will come out to be plus 14 minus 6 will give me plus 8x minus 8. Now I can just multiply it by positive 8, that is plus 8. So plus 8 will give me 8x minus 8. So 8x minus 8 will further divide it. There will be no remainder here. So the values that are coming out will be x minus 1 was already there. So second is x square minus 6x plus 8. So this is for the first, that is in the numerator. Although we can further solve this, we can see that the middle term is minus 6, so I can write it as minus 4 and minus 2. So minus 4 and minus 2 will be minus 6 and the product will be 8. So I can further simplify this and I can write it as minus 4 and minus 2. Sorry, plus 2 it will be, no? So x plus 2. Let me see. No, it should be minus because the product is positive, so it will be minus 2 only. So x square minus 4x minus 2x will be minus 6 and the product is 8. So these are the 3 roots of this particular cubic equation, that are 1, 2 and 4. Now doing the same for the term in the denominator. So we need to again check for the denominator at what value it is coming to be 0, so that we are able to figure out the roots of this cubic equation. Okay, so in here it is given to us as x cube minus x square minus x minus 2. So if we put 1, then it will come out to be 1 minus 1 minus 1 minus 2. So clearly this is not equal to 0. This will come out to be some negative value. Let's check for minus 1. So this will be minus 1 cube minus 1 square minus 1 minus 2. This will be minus 1. So this will be minus, this will be 1 plus 1 minus 2. Again, this is not coming out to be 0. We need to check at 2 also now, putting the value as 2. So this will come out to be 2 raised to power 3 minus 2 raised to power 2 minus 2 minus 2. This will be 8 minus 4 minus 2 minus 2. Yes, so 8 minus 8 is equal to 0 because 4 into 6 into 8. So 8 minus 8 is equal to 0. So we are able to figure out one root of this cubic equation, that is 2. So we will do the same division for this cubic equation also, because 2 is the root, so we will divide it by x minus 2, right, doing the same that we did for the term that is in the numerator. So this will come out to be x cube minus x square minus x minus 2. So this was for the first term. So I'm writing it here then. So multiplying it by x square, so x cube minus 2x square, this will be minus, this will be plus, this will cancel out, this will be, because 2x square is positive, so this will come out to be 2x square minus x square, so plus x square minus x. So now multiplying it by positive x, so this will come out to be x multiplied by x square minus 2x. So this will come out to be minus plus again, this will cancel out, this will be 2x minus x as x minus 2. So just we can multiply it by 1, because multiplying it by 1 will give me the first term, that is x minus 2. 1 multiplied by this will be x minus 2, and there will be no remainder, this will cancel out. So here we are getting x minus 2 and x square plus x plus 1. So because we are already found the roots of the term that is the cubic equation that is in the numerator, now we have solved the term that is in the denominator also, but we won't be able to split the middle term here. But one important thing that you can note here is that this term will always be positive, because the discriminant of this particular term will be equal to, so discriminant is equal to b square minus 4ac, right? So b square minus 4ac will be negative for this particular equation. So that is b square is 1 square, that is 1 minus 4 multiplied by 1 multiplied by again 1. So this is equal to less than equal to 0, because 1 minus 4 will be minus 3. So because the discriminant of this particular quadratic equation is negative, and also if you put any value in place of x, let's say I take a value of x as 2, or let's say minus 2 also, if I take minus 2, so this will be equal to 4 minus 2 plus 1, that is equal to 5 minus 2 is 3. So this will be always positive, right? Putting any value, we are able to see that it is coming to be positive, and the discriminant is always 0, so this particular term will always be positive. Okay, now we are able to figure out the 4 values. So now I can just put the value here. So the numerator is x minus 1, I'm writing it here. So the numerator is x minus 1, x minus 4 and x minus 2 divided by x minus 2, this is x minus 2, x square plus x plus 1. This is less than equal to 0, or not equal to, less than 0. Now we can just cancel out this with the condition that x cannot be equal to 0, because at x is equal to 0, the denominator will be equal to 0, that will come out to be undefined. So x cannot be equal to 0. This is always positive, like just now I told you, this is always positive. So we are left with these two terms. We just need to put it on the number line, that is the critical points will be 1 and 4. X minus 1 is equal to 0, so x is 1, and x minus 4 is equal to 0 will give me x is equal to 4. So 1 and 4 are two critical points. I just need to put it on the number line. So putting these values on the number line will give me 1 here and 4 here. Okay, so putting some value, let's say I put a value that is greater than 4. So if I put x is equal to 5, so x is equal to 5, this will be positive, this will also be positive, so the result will be positive, right? And again I can just write this as negative and this as positive, like I told you. If I'm able to figure out the value or the sign in one interval, I can just interchange the sign, and I can write the remaining the signs in the remaining intervals also, if the power is odd, because this is one power, right? So we can just, because if this is positive, so this will be negative and this will be positive. Now I am asked to calculate the value that is less than 0. So this will, for less than 0 we need to find a value that is negative, right? Less than 0 means negative. So the value will lie in this particular range from 1 to 4, and of course at 1 this will be 0, at 4 also this will be 0, and we are asked to calculate less than 0, so this will be open bracket. So from 1 to 4, all the values in between 1 to 4 will satisfy the conditions, but there is one more condition, that x can't be equal to 2. So because there were two values that are 2 and 3 in this particular range, but we cannot take 2, so there will be the only one possible value that will satisfy this satisfy this inequality, that x will be equal to 3. But because we are asked to calculate how many integral values will satisfy, so the answer will be 1, right? Only one integral value will satisfy the inequality, that is x is equal to 3, because we got the range from 1 to 4 with the open bracket, so 1 and 4 won't be included. 2 cannot be the answer because at 2 the denominator will be 0, that will make the inequality as undefined, so 2 will also be not considered. Only x is equal to 3 will satisfy. So because we are asked to calculate for how many integral values, so because there is only one possible answer, that is x is equal to 3, so the answer for this question will be 1. I hope this should be clear. If you have any doubts you can just ask in the live chat. Otherwise we'll move ahead to the next question then. Yes, Aviral, if you have any doubts you can just ask. Yes, hi Sanjay. Okay, I hope there are no doubts. And yes, Math Magic, your answer is correct. For question number 5 you have written one value. Good going. Try this also. This seems to be an easy question. Try this. Okay, so the time is up. Let's attempt this question then. So log base 25, log base 5, and this particular term is equal to 0. What is the sum of all the real values of x which satisfy the above equation? Okay, let's solve this. In this question we are given, yes, so log base 25, log base 5, and this is x plus 5 plus root x equal to 0. This is what we are given. So we can just take this to the right hand side using the property of log, right? So this, taking this to the right hand side, so 0 will come to the power, so this will come out to be or 1, right? Any number raised to power 0 is equal to 1. Any number raised to power 0 is equal to 1, so I can write it as 1. Okay, so now let's say I'm writing it as 1 only. So now I'll take this also to the right hand side, so this will come out to be 5 raised to power 1 will be 5 only, right? 5 raised to power 1, it is 5. Now I just need to solve this. I can just take this term to the right hand side and just square both the sides. So I can just take this to the right hand side. This will come out to be x plus 5 is equal to 5 minus root x. To solve this, I can just square both the sides. So squaring okay, just squaring both the sides, this will come out to be x plus 5, right? If I square, so the square root will be removed and this will come out to be x plus 5, and here this will come out to be 5 minus root x square. Okay, so this is x plus 5, this will be 25 plus x minus, just doing the square, so 25 plus x minus 2ab, that is 2 into 5 into root x, that is 10 root x. So x and x will cancel out, so 5 equal to 25 minus 5 into 2 is 10 root x. Taking this to this side, this will come out to be 10 root x equal to 25 minus 5 is 20, and just cancel out 0, so root x is equal to 2, so x will be equal to 4. So there is only one possible value of x that will satisfy this condition, that is x is equal to 4, and we are asked to calculate the sum of the real values, that is so 4 only. So the answer for this question will be 4. I hope this should be clear. This was an easy question. If you don't have any doubts, we can move to the next question then. Yes, Saviral, your answer is correct. That is 4 for this particular question. Moving ahead, try this question then. See, if you are starting now, then I would recommend you to give a lot of mocks, because the paper is on 13th, right? So you have only 1 week of time left. We are providing 5 free mock tests. Okay, so your focus should be on giving a lot of mocks, and on the basis of the scores that you are getting in the mocks, you should do your preparation. Okay, of course you won't be able to cover all the topics now. Okay, try solving this question. Okay, so the time is up. Let's see. So in this question we are given that if log with the base 0.3, argument a minus 1 is less than this particular term, then a lies in the interval. So like I told you, if the base is in between 0 to 1, then the sign of the inequality will change, right? So I have included one question on that particular property. Okay, so we are given that log base 0.3, this is a minus 1, less than log 0.09 a minus 1 Yes, so we are given this, right? Now what I can do is I can just write this term as 0.3 square, right? So this is 0.3. So if I write this as 0.3 square, then the base of the two terms will be same. And of course we just want to do we just want to convert the base, we just want the base to be same so that we are able to apply some of the properties. So if the base is different, we won't be able to apply any property. So that's why we will be writing this term as 0.3 square. That is 0.3 square. Now I can use the property of log, that this power will go in the here, but see from here if there is some power, then you can directly write this term here. But if you are taking some power from the denominator, then it will come out to be 1 by that power. That basically means, let's say if you have, right, let's say log with the base 9 and 3 it is written, or let's say log base 3 9. So because 9 is 3 square, so this was 9 3 ka square this is, and you can just write this 3 this power here, that is 2 log with the base 3 and 3, right? You can just take this power here. But in this case what you can do is 3 square, of course 9 is 3 square here. From here also you can take the power here, but this will come out to be 1 by 2. The power will come out to be in the reciprocal form, log 3, right? So if the power is in the argument, you can directly take the power here, but if the power is in the base, then the power will come in the reciprocal form. I hope this is clear. Using the same property here now. Okay, so using the same property here, this will 2 will come here, but in the reciprocal order. So this will be 1 by 2. A minus 1, this is less than, this 2 will come out here as 1 by 2. Now I can just take this value to the left hand side. So this will come out to be 2 log 0.3 a minus 1 less than equal to log 0.3 a minus 1. I can also take this term also to the left hand side. This will come out to be 2 log 0.3 a minus 1 minus log base is 0.3, argument is a minus 1, this is minus, that is less than 0. Okay, now these two terms are same. So if this is, let's say, k, so 2k minus k will give me k only. So this will be log with the base 0.3 a minus 1 less than 0, right? Because both the terms are same. So 2 times some value minus 1 time the same value will give me only 1 time that particular value. So this will come out to be log with the base 0.3 argument a minus 1 less than 0. Now I can just take this value to the right hand side. So this will come out to be 0.3 raised to the power this 0. But again, because the argument is in between 0 to 1, then the inequality will change. So this will be greater than a minus 1, right? This was the important point to note here, that because the base is in from 0 to 1, so the when we will be taking this to the right hand side, the inequality will change. So from less than, this will turn out to be greater than. So because any number raised to power 0 is 1 only, so 1, yes, so 1, I think I made some mistake here, 2 less than 0. Okay, so this is log with the base 0.3 a minus 1 is less than 0. So I can write it as a minus 1, but the sign will change, 0.3 raised to the power 0, right? I just took this value on the left hand side, so the changing of inequality will make no sense, right? So we will write the same term here, and we'll just take this value to the right hand side, and the sign of the inequality will change. So this will come out to be a minus 1 greater than equal to, because this is raised to power 0, any number raised to power 0 is 1, so this will come out to be 1. So a will be greater than, I am just taking this to the right hand side, will be 2. So a will be greater than 2. That is option number B. I hope this should be clear. If you have any doubts, you can just ask in the live chat. Otherwise, we'll move ahead to the next question then. Yes, the option B is the answer. No, Abhiraj, the answer will be option number B. If there are any no doubts, we can move to the next question then. Yes, try to solve this. Okay, so the time is about to end. We'll start solving this question then. Okay. So what values of x satisfy the following equation, that is this? Okay. So let's try to solve this now. I'm solving it here. So this is 1 divided by x minus 2 plus 1 divided by x minus 5. This is greater than 1. Okay. Now we can just solve it by multiplying the denominator. So we can just multiply here. So 1 multiplied by x minus 5 plus this term will be multiplied here, that is 1 multiplied by x minus 2. This will be x minus 2 and x minus 5. Right, this is greater than 1. I've just simplified it. This will come out to be x minus 5 plus x minus 2 this will come out to be x square minus 2x and minus 5x. So minus 2x minus 5x will be minus 7x. Minus 2 into minus 5 will be plus 10, right? This is greater than 1. So this is 2x minus 7 divided by x square minus 7x plus 10 greater than 1. I can also take this one to the left hand side. What I'll get here, I'm writing this here, that is 2x minus 7 divided by x square minus 7x plus 10 minus 1, I have taken this minus 1 to the left hand side, greater than 0. Solving this now, this will give me 2x minus 7 minus 1 x square minus 7x plus 10 divided by x square minus 7x plus 10, that is greater than 0. This will come out to be minus x square plus 7x minus 10, right? So this will come out to be 2x minus 7 minus x square plus 7x and minus 10. In the denominator it is x square minus 7x plus 10, that is greater than 0. Again this is minus x square plus 9x minus 17, okay, and in the denominator it is x square minus 7x plus 10. Now to make this term as a positive, we will just take minus as common and we will multiply both the sides with minus 1, so the inequality sign will change. Okay, doing it here, this will come out to be, if I take minus common, this will come out to be x square minus 9x plus 17, right? So I've just taken the minus as common, so either you can write minus as the common here, x square minus 7x plus 10. So now because we have taken the minus as common, now we will be just multiplying both the sides with minus 1, so we will be able to remove this minus 1 and the sign of the inequality will change, because this was greater than equal to 0, not equal to, this was greater than 0, now this will come out to be less than 0, right? Now because we don't know the sign of this particular term, so we can't just multiply to the right hand side, we can just take it to the numerator only, or what you can say is, whenever we have two terms, for example if you have some terms in the numerator, you have some terms in the numerator and also you have some terms in the denominator that is less than 0, so you can consider it as both the terms in the numerator, okay, you can consider both the terms in the numerator. Or what you can do is, to better understand this, let's say if you are multiplying by x square minus 7x plus 10 in the numerator also, in the denominator also, then you will be getting both the terms in the numerator itself, and in the denominator it will become x square minus 7x plus 10 whole square, and because it is a whole square, that means that is a positive term, so you can just take it to the left hand, this particular side, that is right hand side, and with multiplying it by 0, this will be 0, right? So either you can just multiply this term, the numerator as well as denominator, with x square minus 7x plus 10, then you can just send this to the right hand side, or you can consider this particular equation as x square minus 9x plus 17 multiplied by x square minus 7x plus 10 less than 0. Both the conditions are same, okay. Now you just need to solve these two quadratic equations. Here you can see that you won't be able to break the middle term, right? You won't be able to split the middle term because the product is 17 and the sum of the two values should be 9 or minus 9, but here you will be able to break, right? Because the product is 10, so you can write minus 7 as minus 5 and minus 2. So for this particular equation, you will have to use the formula that minus b plus minus under b square minus 4ac. So you will be required to use that particular formula here, but you can solve this particular term, that will come out to be x minus 5 and x minus 2, right? You can write this as minus 5 minus 2, and then you will just take x common and you will be able to figure out this. We have solved this in the previous questions also, so I think you will be able to solve this. I am just saving some time here, okay. So for this particular term, you can just use the formula that minus b plus minus under b square minus 4ac formula to get the roots of the equation. I'm doing it here. So in this question, the value of b is minus 9. So minus of minus 9 plus minus under root b square. b square is minus 9 square, that is 81 minus 4. A is 1 because there is the coefficient of x square is 1. So this is A will be 1 and C will be 17. So 4AC will be 4 into 1 into 17 divided by 2A. Okay, divided by 2 into A. Again the coefficient of A is x square is 1. So this will be 1. So this will come out to be 9 plus minus. So 17 into 4 is 68. So 81 minus 68 will be 13. So this will come out to be root 13, right? 81 minus 68 is 13 divided by 2. So the approximate value of this particular term will be, because this will lie in between 3 to 4, right? 3 square is 9, 4 square is 16. So this term will lie between 3 and 4, approximately 3.4 or 3.5. So just the approximate value that you can get here will be, I'm writing it here, let's say 9 plus 3.5 divided by 2. That will be 12.5 divided by 2, somewhere close to 6.23 something, right? Some random value, just the approximate value I am taking. If I take the minus sign, then it will be 9 minus 3.5 something. So this will be 9 minus 3.4 or 3.5 something divided by 2. So this will be 9 minus 3 is 6. So 6 point something or maybe 5.5 divided by 2. So this will come out to be either 3 point something or maybe 2.8, 2.7 something like that. Okay, so these are the approximate values of this particular approximate value of the roots of this particular quadratic equation, right? We already know the other two roots. Now we just need to put in on the number line, right? I'm framing the number line here. So these two roots are these two critical points are x minus 2 is equal to 0 will be x is equal to 2, and x minus 5 equal to 0 will be x is equal to 5. So the two roots here or the two critical points here are 2 and 5. So it will be 2 and 5. This value is close to 3 or 2.8 something. So this particular root will lie here, that is 9 minus root 13 divided by 2. And the second root is close to 6, right? So this will be greater than, of course, it is greater than 5. So this root will lie here, that is 9 plus root 13 divided by 2. So these are the four roots that we have put in on the number line. Now we just need to see in which interval or answer we are asked to calculate the values. So we need to see the overall result should be less than 0, right? So the overall result should be less than 0. Putting some values in this particular range or this particular interval, this is 6 point something. So let's say we are taking value as 7. So if we put the value as 7, so 7 into 7 is 49, minus 7 into 6 is 63, plus 17. This will come out to be 66 minus 63. So this will be positive, right? So here it will be positive. And like I told you, because the power of all the terms is 1, so you can see the power is 1, that is odd. So we can just directly write, if this is positive, then this will be negative, this will be positive, this will be negative, this will be positive, and so on, right? And because we are asked to calculate less than 0, that is negative values, so negative values are coming in this range as well as this range. So these two ranges, or you can say these two intervals, the value is coming out to be negative. So how you will be writing it? From 2 to 9 minus root 13 divided by 2 union 5 comma 9 plus root 13 divided by 2. Again, because this is not equal to, right, this is less than 0, and at the critical points this term will be equal to 0, and we are not asked to calculate equal to 0. So the bracket will be open, right? The end values will not be counted. This will not be a closed bracket because this is less than 0, and at the critical point this will be equal to 0. Okay, so this will be the answer, that is from 2 to 9 minus root 13 by 2 union 5 comma 9 plus root 13 by 2. So from there this should be the answer then, that is from 2 to x, from 2 to 9 minus root 13 by 2, this is union 5 from 5 to x 9 plus root 13 by 2, that is this. I hope this should be clear. So answer for this question will be option number C. If you have any doubts, you can just ask, otherwise we'll move on to the next question then. Okay, so moving on to the question number 9 then. Yeah, so Aviral, you are asking how I didn't get the step of taking the denominator to the numerator. See, if we have any value, for example, if you have taking some smaller values, let's say this is x minus 2 divided by x minus 5, this is less than 0. Suppose this is given to you. So either what you can do is you can just multiply x minus 5 to the numerator as well as denominator. So what will happen is you will be multiplying x minus 5 in the numerator and denominator. So this will be perfect square, right? Because if you are multiplying it by x minus 5, so this will be perfect square number. This is perfect square. Now because this is a perfect square number, so you can just take it to the right hand side and the sign of the inequality will not change. Because if you are multiplying with any positive number, like I told you in the initial slides, that if we are multiplying it with some positive numbers, then the sign of the inequality does not change. But if we are multiplying it with negative numbers, then the sign of inequality will change. Here we do not know what will be the sign, so we just can't multiply it to the right hand side. So either, because we cannot directly multiply to the right hand side, what we can do is we can just make it as a positive number by making it perfect square. We have multiplied by x minus 5 in the numerator and denominator. Now we can just multiply this term to the right hand side. So that's what I was saying, that if we are given the values, let's say in this particular format, so you can consider this equal to this, right? Even though the logic is this, that you are multiplying the numerator and denominator with the same value, but to ease your calculation, instead of doing this, you can just consider this same as this, right? So you can consider this value as x minus 2 multiplied by x minus 5 is less than 0. So this and this is giving the same answer. I hope this should be clear now. Okay, so the time is up for this question. We'll attempt this question now then. Let's attempt this question now. Question number 9. So in this question we are asked to calculate, okay, so if x and y are real numbers such that the value of x lies in the range from minus 6 to minus 2 and the value of y is lying from the range minus 4 to 4, the value of z is lying from 3 to 7, the value of w is y divided by x into z, which of the following is necessarily true? Okay, so from the options we can see that we are asked to calculate the range of w, right? We are asked to calculate the range of w. So range means we need to find the maximum as well as minimum value of w. So let's try to find the maximum as well as minimum value of w. So w is y divided by x into z. Let's see what the values are given to us. The value of x is from minus 6 to minus 2. So x is basically, this is closed bracket, from minus 6 to minus 2. Y is from minus 4 to 4. Again this is closed bracket because this is equal to sign. And for z again this is closed bracket from 3 to 7. Let's first try to find the maximum value. Now you can see that x is always negative, right? Whatever value you take from this particular bracket, x will be always be negative. And for z, this is always positive. So whatever value you take from x, whatever value you take from z, this product will always be negative, right? And to make this particular term, that is w, as a maximum, you will want to take the value of y as negative, because the denominator is always negative. So if the numerator is also negative, then negative and negative will turn out to be positive number, and you want to maximize, right? So to maximize, because the denominator is negative, you will want to take a negative value in the numerator also. So that was the first thing to note. Second thing is that because you want to maximize this, you will want a smaller value in the denominator, right? When the denominator is smaller, then only you can get a larger value overall, right? So now to get a smaller value, what you can do is you can take the smaller values, right? So the small value that you can take from this particular bracket for x is -2, and from this particular bracket the small value that you can take is 3, because you want a small value in the denominator. So the overall answer is a maximum. So this is -2 multiplied by 3, right? So this is in the denominator, and because you want to maximize, you can just take the negative value, because this is already negative. You'll want to take a negative value and the maximum negative value, because the overall answer you want is to be the greater, you want to maximize w, so you'll want a larger value for w, larger and also negative, because the denominator is also is always negative. So we are taking -4 from here, that is the largest possible value that we can take. So minus and minus will cancel out, so this will come out to be 2/3. This is the maximum possible value of w. Now using the same logic, we can find the minimum value also. So the maximum value will be 2/3. Now we need to find the minimum value also. See, for minimum value again, because we know that the denominator is always negative, that is equal to this particular term. So denominator is always negative, that is -2 multiplied by 3, right? And because you want to minimize this value, you will take a positive value in the numerator and a greater value, right? A positive value in the numerator and the negative value in the denominator will give me overall a smaller answer, right? So we can minimize w by that. So taking 4, that is the maximum value that we can take in the numerator. So this will come out to be 4 here. So solving this will come out to be again 2/3, but now negative sign, right? So this is coming out to be the minimum value. So the minimum value of w is -2/3, and the maximum value of w is +2/3. So the w will arrive in the range of from -2/3 to +2/3. That is in the answer, option number D. So it will lie in the range of -2/3 to +2/3. I hope this should be clear. This was just a logical question. I hope this should be clear. If you have any doubts, you can just ask, otherwise we'll move ahead. Yeah, Aviral, it is good that you are able to understand the last question. I hope this is clear. Moving ahead to the last question of the day. You need to find the range of this expression. Okay, and of course x is real. Okay, so the x is real and you need to find the range of the expression. Yes, Sanjay, you can ask whatever doubt you have. Yeah, this is the last question for today, Sanjay. Okay, so the time is about to end. We'll try to attempt this question. Okay, so we need to find the range. So the range basically means what all values can come from this particular equation. See, there are two terms that are domain and range. Domain basically means what all values you can put in place of the variable. So whatever value I can put in place of x will be domain, and whatever the output will come is the range. Okay, so we need to find the range. Let's solve this. So we are given that x square minus x plus 1 divided by x square plus x plus 1. Right, so we are given this and we need to find the range. That means what all value can come. Right, so let's say the answer for this particular question is k. Right, now we need to find what all possible values of k can be there. Right, range basically means what all results can come. Whatever value you put in place of x, what is the maximum and minimum possible value that can come, right, for this particular expression. Let's say the answer is k and I need to find what all values can k take. Okay, now solving this, I am taking this particular term to the right hand side. So this will come out to be x square minus x plus 1, that is equal to k multiplied by x square plus x plus 1. Okay, so x square minus x plus 1, that is equal to k square kx square kx square plus kx plus k. So solving this, I am taking this to this right hand side. So this will be kx square minus x square plus kx minus x will be plus x here plus k minus 1 equal to 0. Right, because I have taken this term to the right hand side, so here it will be 0. I can write 0 here also, I can write 0 that particular side also. Okay, so now taking x square common, this will be k minus 1 plus x k plus 1 plus k minus 1, it is equal to 0. Right, so again we are able to frame the quadratic equations. And now because x is real, then the discriminant of this particular equation should be greater than 0. Right, I told you that we need to solve this for real values of x, and if x is real, then the discriminant, that is b square minus 4ac, should be greater than 0. So discriminant, that is d, should be greater than 0, b square minus 4ac should be greater than 0. Right, so discriminant should be greater than 0. So b square is this, the b term is this, a is this, and c is this. So solving this will here, so b will be k plus 1, so k plus 1 square, that is b square minus 4, a is k minus 1, c is also k minus 1, so this should be greater than 0. Right, so the discriminant should be greater than 0. So this is k plus 1 whole square, that is k square plus 1 plus 2k minus k minus 1 into k minus 1 is k minus 1 whole square, so minus 4 k minus 1 whole square greater than 0. So this is k square plus 1 plus 2k minus 4, see k square, k minus 1 whole square is k square plus 1 minus 2k. So this is k square plus 1 minus 2k. Okay, now solving this further, this is k square plus 1 plus 2 times of k minus, this will be 4 times of k square minus of 4 into 1, that is 4, and this is plus of 8k, right, 4 into 2 is 8, so plus 8k. greater than 0. Now just writing it in the form of quadratic equation, that is minus 4k square plus k square plus 2 times of k plus 8k plus 1 minus 4 greater than 0, right? So this will be minus 3k square plus 10 times of k minus of 3 greater than 0, right? So I'm further solving it here. So this is, again, because the k square term is negative, what I can do is I can just multiply both the sides by negative sign, so that the term associated with k square is positive and the inequality sign will change. Okay, so this will become 3k square minus 10k plus 3, this will be equal to less than 0. I hope this should be clear. So this is the final inequality, that 3k square minus 10k plus 3 is less than 0. I am further solving it here. I hope this will be visible here. I am writing it here now. Now again we can just split the middle term if it is possible. So minus 10 I can write it as minus 9 minus 1, that is minus 9 minus 1 will be added to minus 10 will minus 9 minus 1 will add up to minus 10, and the product of minus 9 and minus 1 is plus 9, that is 3 into 3 is plus 9. So we can easily split the middle term. So I'm solving it here. So this will be 3k square minus 9k minus k, right? Minus 9 and minus 1 will be equal to minus 10, and the product is equal to product of the extremes, that is 3 into 3 is 9. Okay, the last term is plus 3. So this is less than equal to, not equal to, I'm again saying equal to, so this is less than 0. So this will be equal to, so now we need to just take some common. So 3k is common, so this will be k minus 3, right? I have taken 3k as common, so this will be k minus 3, here it will be minus 1, this will be k minus 3 less than 0. So this will come out to be k minus 3, 3k minus 1 less than 0. Now we just need to put it on the number line. First we need to check the critical points. So k minus 3 is equal to 0, so k will be 3. 3k minus 1 equal to 0 will give me 3k is equal to 1, so k will be 1 by 3. So there will be two critical points that are 1 by 3 and 3. So these are the two critical points that are 1 by 3 and 3. Now taking some value that is greater than 3 in this particular interval. So if I put k is equal to 4, so this will be positive, 4 minus 3 is positive, and 4 into 3, 12 minus 1 is also positive. So the result will be always positive. So here you can write positive, and again because all the terms have the power as odd number, that is 1, so you can just write minus the negative here and the positive here. We are asked to calculate less than 0, right? We need to find the negative values. So negative values are coming in this particular interval. So we are able to figure out the range of k, right? So we have let the value of this particular term as k, and the maximum and minimum value of k we are able to figure out. That's what we were asked to calculate. So the k will lie in the range of 1 by 3 to 3 with open bracket. Again, because there is no equal to sign, so there will be open bracket. So k will lie in the range of minus 1 by 3 to 3. That is option number D. That is basically the answer for this question. I hope this should be clear. If you have any doubts, you can just ask. Otherwise, we'll just end this session now. If you don't have any further doubts, Sanjay, you can get more questions by solving the test that we are providing, right? Right. So you can join this particular WhatsApp channel. We are providing free preparation resources, so there you will be able to get the free questions, right? we are providing daily targets also for this particular entrance exam. So that's why I told you, if you want to prepare, so you can just join the WhatsApp channel. The link is given in the description box. All the free preparation resources are shared there, and any important updates regarding the exam as well as the session that we are conducting, all will be shared in this particular WhatsApp channel. And also someone was asking about how to prepare. So because only 1 week time is left, so because you won't be able to do all the topics now, so it is important to give the mock test, and on the basis of whatever you are able to perform in the mock test, you can just do the preparation on the basis of the test performance, right? So these are the free 5 mock tests that we are providing, right? All you need to do is just visit the website, that is cracku.in/IIM Bangalore UG mock test. You just need to register yourself, and you will be able to give these 5 free mock tests. These are prepared by experts. Okay, so this was about it for this session. Why no d greater than equal to 0? Raguraj, can you please mention in which question you are asking? Or what you can do is, you can just mention the question number and you can ask in the comment box. After the session, I'll answer it, because I need to end the session now. It is already more than 2.5, close to 2.5 hours now. So I need to end the session now. Whatever doubt you have, you can just put it in the comment box and I'll answer it. Okay, and the videos for logical reasoning and DI are also uploaded on this particular channel also. Okay, so you can just subscribe our channel. On this particular channel only, you will be able to find all the videos for logical reasoning and DI also. We have conducted all the sessions for free, right? Complete syllabus is being covered on this particular channel. You can just subscribe to the channel and you will be able to find all the videos. I hope this was clear. Yeah, thank you, Sanjay. Okay, so that was it about this class. Thanks for joining in. And if you have not subscribed to this channel, I would request you to subscribe, so that motivates us also to bring so many free sessions for you. And also, if possible, you can like the stream also. Okay, so thanks for joining in and take care.